Hidden within the sun's glare lies Mercury, the smallest planet in our solar system. Its swift orbit and close proximity to the sun make it a challenging subject for observation. What we have discovered is a planet of stark beauty and unparalleled hostility. The sun's light and heat bathe Mercury in a relentless torrent of energy. Join us as we venture onto the surface of Mercury, a planet where the very laws of nature seem to conspire against the existence of life as we know it. Mercury stands apart from its planetary siblings as a world forged in fire and sculpted by gravity. Its most striking characteristic is its extraordinarily high density, hinting at a massive iron-rich core. This iron heart shapes Mercury's magnetic field, a surprisingly robust feature for a planet of its size. The planet's surface is a desolate landscape of craters, plains and cliffs, a testament to billions of years of bombardment. It is a landscape both alien and strangely familiar, echoing the barren beauty of our own moon. The sun, giver of life and energy, reigns supreme over our solar system. On Mercury, its proximity transforms this life-giving force into a weapon of unimaginable power. During its long days, temperatures can soar to a staggering 800 degrees Fahrenheit. Without a substantial atmosphere, temperatures plummet dramatically during Mercury's equally long nights. It is a world of fire and ice, where survival would require technology far beyond our current capabilities. Imagine stepping onto Mercury's surface, a vast, undulating plain of rock, baked and scarred by the sun's relentless heat. The rocks beneath your feet would be hot enough to melt lead, their surfaces shimmering with an ethereal glow. As you look across this alien landscape, you notice vast plains interspersed with towering cliffs and craters. Unlike Earth, where erosion and geological activity have softened the planet's features, Mercury's surface bears its scars openly. The starkness of the landscape and the silence create a sense of awe and isolation unlike anything imaginable on Earth. On Earth, we take our atmosphere for granted, but on Mercury, the atmosphere is so thin as to be practically non-existent. Without an atmosphere to scatter sunlight, the sky above would be an inky black, even during the day. Any human venturing onto the surface would need a pressurized suit with an independent oxygen supply just to survive. The silence without air to carry sound waves would be eerie, broken only by the hiss of your oxygen supply. Five seconds on Mercury without a spacesuit would be an eternity. The intense heat would hit you with the force of a blast furnace, while the extreme cold of the vacuum would take hold on the other side of your body. Your lungs, starved of oxygen, would desperately try to draw breath. The pain receptors in your body would be firing on all cylinders, sending a torrent of signals to your brain. You might experience a strange sense of detachment as your body struggles to process the impossible situation. 3 seconds into your ordeal, the two extremes of Mercury's environment would be waging a macabre battle across your body. The side facing the sun would be a charred ruin, while frostbite would be setting in on the shaded side. Your vision might blur, the edges of your sight fading to black as your brain struggled to process the conflicting signals. Inside your body, deprived of oxygen, your organs would be screaming out in protest. Through the haze of pain and confusion, you might catch a glimpse of the Earth, a poignant reminder of the life you are so rapidly leaving behind. 4 seconds. Your circulatory system, starved of oxygen, would begin to falter. The sheer magnitude of the temperature extremes would overwhelm even the most robust survival mechanisms. Inside your cells, the intricate chemical reactions that power your cells would grind to a halt. Yet, amidst this cascade of failures, your brain might still cling to a flicker of consciousness. 5 seconds. By now, the damage to your body would be catastrophic and irreversible. Your heart, starved of oxygen, would likely enter into a state of fibrillation. Your brain, the seat of your consciousness, would be on the verge of complete shutdown. Your 5-second journey to Mercury would be over, a stark reminder of the importance of understanding the limits of human endurance. This grim scenario underscores the crucial role of spacesuits in protecting astronauts from the hazards of space exploration. A spacesuit is far more than just clothing. It is a personalized spacecraft, a marvel of engineering designed to keep its wearer alive. For a visit to Mercury, even a brief one, a spacesuit would need to be exceptionally robust. It would need to provide a pressurized environment, advanced cooling and heating systems, and superior radiation shielding. A Mercury-bound spacesuit would require a robust life support system, ensuring a constant supply of oxygen and monitoring the astronauts' vital signs. Even with a spacesuit robust enough to withstand Mercury's extremes for a few moments, surviving 5 seconds is only the first hurdle in a race against an unforgiving environment. The real challenge lies in extending that survival time, in creating technology that allows humans not just to exist on Mercury, but to explore and study this enigmatic world. Imagine a future where specially designed rovers, hardened against radiation and equipped with advanced cooling systems, could traverse the scorched plains of Mercury. These robotic explorers, controlled remotely from Earth or perhaps from a future orbiting outpost, could collect valuable data about the planet's composition, magnetic field, and geological history. But what about human exploration? The prospect, while daunting, isn't entirely outside the realm of possibility. One concept envisions the creation of shielded habitats, perhaps located in permanently shadowed craters at Mercury's poles, where temperatures are significantly lower. These habitats, potentially built using 3D printing technology and resources mined from the planet itself, could provide a safe haven from the sun's wrath. Furthermore, advancements in material science could lead to the development of spacesuits with even greater thermal protection and radiation shielding. Imagine suits equipped with internal cooling systems capable of dissipating heat far more efficiently than current technology. Such suits, coupled with exoskeletons to aid in movement under Mercury's increased gravity, might one day allow astronauts to venture out onto the surface for extended periods. The Sun, the lifeblood of our solar system, poses the most significant challenge to any attempt to explore Mercury. Its proximity bathes the planet in intense radiation, making any prolonged exposure for humans incredibly dangerous. Overcoming this challenge requires innovative thinking and a willingness to push the boundaries of our current technological capabilities. One promising avenue of research involves the use of magnetic shielding. Just as Earth's magnetic field protects us from harmful solar radiation, artificially generated magnetic fields could be used to create protective bubbles around habitats and even spacesuits. These magnetic shields would deflect charged particles from the Sun, creating a safe zone for human exploration. Another area of exploration is the development of radiation-hardened materials. Scientists are constantly searching for new materials that can withstand the damaging effects of radiation. These materials could be used to construct everything from spacecraft and habitats to spacesuits and scientific instruments, providing a more robust defense against the Sun's onslaught. Furthermore, exploring innovative construction techniques, such as utilizing the natural shielding provided by Mercury's terrain, could be crucial. Underground habitats, shielded by layers of rock and regolith, could offer significant protection from both radiation and temperature extremes. Such habitats, powered by solar energy collected in less hostile areas and transmitted wirelessly, could provide a sustainable foothold for human presence on this challenging world. While the challenges of surviving on Mercury are immense, there is a glimmer of hope in the most unexpected of places: Earth's moon. The experience gained from future lunar missions, particularly the establishment of a permanent lunar base, as envisioned by NASA's Artemis program, could prove invaluable in preparing for the rigors of a Mercurian expedition. The Moon, like Mercury, lacks a substantial atmosphere and experiences extreme temperature variations between day and night. While the lunar environment is less extreme than Mercury's, the challenges of building habitats, generating power, and protecting astronauts from radiation are remarkably similar. The technologies developed for lunar exploration, such as advanced life support systems, radiation-resistant materials, and in-situ resource utilization techniques, could be adapted and enhanced for use on Mercury. Furthermore, the experience gained in operating in a harsh airless environment will be invaluable in training astronauts and developing the operational protocols necessary for a successful Mercurian mission. In many ways, the Moon can be seen as a stepping stone, a testing ground for the technologies and strategies that will be needed to conquer the challenges of exploring the inner solar system. The lessons learned on the Moon, combined with focused research and development, could pave the way for humanity to eventually reach out and touch the fiery surface of Mercury. Spending 5 seconds on Mercury opens up a Pandora's box of challenges and possibilities. It highlights human limitations, but also our determination to push beyond them. We are creatures of Earth, evolved to thrive within its protective embrace. Venturing into space requires creating artificial environments to survive. The pursuit of knowledge is a testament to our spirit of exploration. The desire to understand the universe compels us to push boundaries. The challenges of Mercury are a call to action, an invitation to explore. For centuries, Mercury remained an enigma, its searing surface and swift orbit keeping its secrets hidden. The space age finally allowed us to unravel the mysteries of this enigmatic world. Each mission brought us closer to understanding Mercury. The challenges of reaching Mercury are substantial. Its proximity to the Sun means intense gravitational forces and scorching temperatures. Yet humanity has persevered, sending robotic emissaries to gather data. The knowledge gained has deepened our understanding of Mercury and our solar system. In 1973, humanity glimpsed Mercury's surface thanks to Mariner 10. This mission used a gravity assist from Venus to reach Mercury. Mariner 10 made 3 flybys, sending back the first close-up images. The images revealed a heavily cratered surface similar to our Moon. Instruments detected a weak magnetic field, suggesting a molten iron core. Mariner 10's mission was a resounding success. Decades later, new missions would map the entire planet. Section 3. Messenger's Revelations, Mapping the Surface, Unveiling the Depths. NASA launched the Messenger spacecraft in 2004. Messenger orbited Mercury, studying its composition, geology, and magnetic field. It mapped the planet, revealing stunning diversity and beauty. Volcanic activity shaped Mercury's surface, and ice deposits were found in shadowed craters. Messenger discovered Mercury's magnetic field is offset from its center. The mission ended in 2015, but its data continues to provide new insights. Section 4, Bepi Colombo's Quest, a deeper dive into Mercury's mysteries. Bepi Colombo, a joint mission by ESA and JAXA, launched in 2018 and is en route to Mercury. Named after Giuseppe Colombo, it aims to uncover Mercury's secrets. The mission includes 2 spacecraft, MPO and MMO, for a comprehensive study. MPO will study Mercury's surface and interior, while MMO will focus on its magnetic field. Section 1. Mercury, a testament to the universe's power. Our journey to Mercury, even if only a thought experiment in survivability, has revealed a planet of stark beauty and harsh realities. It underscores the immense power of the Sun, transforming it from a life-giver to a force of intense heat and radiation. Mercury stands as a testament to the extremes our universe can produce, a stark reminder of the delicate balance that allows life to flourish on our own planet. 5 seconds on Mercury without protection is a death sentence. The searing heat, the lack of breathable air, the intense radiation, all these factors conspire to make Mercury a hostile and unforgiving world. Yet this very hostility is what makes Mercury so fascinating to us. It is a world of extremes, a natural laboratory where we can study the fundamental forces that shape our universe. While the prospect of human exploration of Mercury might seem like something out of science fiction, the technological advances we're making, spurred on by our insatiable curiosity, suggest that it may not be entirely outside the realm of possibility. Perhaps one day, future explorers, clad in advanced spacesuits and equipped with cutting-edge technology, will walk upon the surface of Mercury, not for mere seconds, but for hours or even days, unraveling its mysteries firsthand. Understanding Mercury is about more than just satisfying our curiosity. It is about gaining a deeper understanding of our place in the cosmos. By studying other planets, particularly those as extreme as Mercury, we gain a new perspective on our own world. The knowledge gained from exploring Mercury could one day be crucial to our survival as a species. For now, Mercury remains a distant and challenging world, a testament to the power of the universe.